Welcome back to my IP version 6 lesson series of videos. Here I am going to compare IP version 4, IP version 6. My name is Kundan. I am from technical team of Networkers Home. Here is chart in front of you. That is IP version 4 and IP version 6 header. So IP version 6, 4, if you will find, we have lots of content there. Like version, header length, types of services, total length, identification, flag, fragment offset, time to leave, protocol, header checksum, source, destination address, option, and padding. On the other hand, version parameter is same. Then header length, that part we did not have in IP version 6. And type of services become class of service. And new content we have, that is flow label. Then again, identification, flag, fragment offset, header checksum, time to leave protocol, header checksum, this part we are not having. And then time to leave protocol, this section name change in IP version 6. For that we have the payload length, next header, and hop limit. After that we have source address, destination address. So we can say IP version 6 is very simple and more informative in comparison of IP version 4 header. It also having extension header features in which IP version 6 header, that is 40 octet. Then it consists any number of any number of extension headers. Data, for example, TCP, UDP. It consists all these information. Then we have hop by hop header format. It consists an extension header processed by each intermediate router. Each intermediate router, which information they are processing, which information they are executing, implementing, carries, all this information it consists. In this way, next header value, hop by hop header, IPv6 header, hop by hop header. And then extension header reserve and type length value encoded options we have. And destination offset header having extension header and contains information only intended for the destination nodes. This information it having. And we have the fragment header option is used when a node must send a packet larger than path MTU. When it's packet larger than path MTU, then fragment header options comes into picture. An IPsec authentication header here with IPv6 basic header and IP version 4 having next header extension 51, either IPv6 header, authentication header we have. Then it having length, reserve, security parameter index, sequence number, authentication data, that is the variable. And IPsec encapsulating security payload header, same thing here we have. There we have the next header 50, here we have IPv6 header and ESP header. Then next header option we have the reserve, security parameter index, sequence number, encryption parameters, encryption date, encrypted data, and ESP tailor. Then it also consists upper layer headers used for transport function for TCP or UDP and must be the last extension header. So here we have the option that we have the IPv6 header, any number of the extension header, data UDP, and the user UDP checksum must be computed. That option we have here, UDP checksum must be computed. And these are the extension header options syntax we have, that it consists hop by hop header, routing header, fragment header, authentication header, ESP header, and upper layer header. Now we will discuss IPv6 operation. We will defining and configuring how we have, what is the neighbor discovery mechanism. All this function we are going to discuss. IP version 6 doesn't consist of resolution. In place of R, it uses ICMPv6 neighbor discovery mechanism. It consists ICMPv6 type, code, checksum, and IP version ICMPv6 data part. It provides diagnostic and error messages. It is used for path, MTU discovery. In IP version 4, MTU is of greater or equal to 68 octet. Here it is 1280 octets, and path MTU used here. And neighbor discovery queries for the duplicate address detection. This is the first work performed by router after assigning IP version 6 address. Under IP version 4, using GAP utility when DSCP remains configured, then it detects duplicate address. But that feature is in the IP version 6. After assigning IP addresses on router's interface, it first performs duplicate address detection. It generates queries for duplicate address detection, determines the link layer addresses of a neighbor on the same link, find neighbors routers on link. This is achieved by using ICMPv6 with IPv6 multicast. FF02:1 for all users, FF02:2 for all routers on the same subnet. Here we have the solicited node address, multicast address with a link scope formed by a prefix and rightmost 24-bit if of every unicast and anycast address. As we know, IP version 6 supports unicast, multicast, and anycast. Multiple nodes, multiple users, multiple servers can represent through one IP that is called anycast. So 24-bit of every unicast and anycast address it consists. And first option we have the IPv6 address, and second option we have IPv6 solicited node multicast address. And then we have the multicast prefix for Ethernet multicast and corresponding Ethernet address that is explained here properly. Now, duplicate address detection. DAD use neighbor duplicate address detection use neighbor solicitation to verify the existing of an address to be configured. So, which address already assigned, it could not configured under IP version 6. It has ICMP type, that is 135, source : destination solicit node multicast of A. Then we have link layer address of A. And then we have query, which is your link. What is your link local address asked by A to B? And then from B, the source is B, destination A, data link address of the B. It provides this information that I have different address, what you have. So now packets from the link can be exchanged because they have all the separate IP. Their IPs are not the same. Their address are not the same. So neighbor discovery options we have R. If with R flag, that is router flag, indicates sender is the router. Solicited flag indicates S, that is message, indicates message sent in the response of a neighbor solicitation. And then we have the O, override flag, indicates advertisement should overwrite existing neighbor cache entry. So these three flags we have R, S, and O. Auto configuration is the unique features which we have in IP version 6. If we have the two server, that will generate router advertisement and user will get automatic based upon the preference which we want to set. And then in that case, default load generate automatically based upon that. Host can access anywhere. This is stateless. Uses neighbor discovery router advertisement, and stateful uses DSCP v6 address. It's stateless when router advertisement generates, and we have the stateful when we have the DSCP services are there. That is IPv6 address DSCP. Automatically it can assign addresses. What we have in IP version 4, but this feature comes under stateful option. So here you have the two PCs and we have the two router. So both are sending router advertisement, which consists ICMP type 134, source, router link local address, destination all nodes multicast address, that is FF02 FF02 : 2, that is all routers on the net. And options, it consists data path, options, prefix, lifetime, auto configuration flag. And router sends periodic router advertisement to all nodes multicast address. I've already mentioned when user receives automatic IP using auto configuration feature, default router, it finds automatically, it receives IPv6 network prefixes information, and what the lifetime of advertisement, that time frame it also receives. And router solicitation packet is fine, that is ICMP type 133, source unspecified address, destination all routers multicast address. At boot time, nodes send router solicitation to promptly receive router advertisement. So router solicitation from the that users to router and router advertisement from routers to the user. So solicitation having ICMP type 133, router advertisement that is 134, source per double colon, who will become going my default gateway. And then it provides its router link local address, destination all routers multicast address, and in the solicitation part, advertisement, it consists all nodes multicast address. Query from the user type, please send router advertisement. And then we have the data option, prefix, lifetime, auto configuration flag. Router solicitation are sent by booting nodes to request router advertisement for configuring the interface. What we required, as we have the option IPv6, obtain IP automatically, that option we have IPv6 address auto config default, and based upon that they are receiving automatic IP from the server. The renumbering part we have, renumbering is achieved by modifying the router advertisement to announce the old prefix with a short lifetime and the new prefix. Suppose we have two servers on a net. So which server we have added next new and which should get the preference first, that is, we have the IPv6 neighbor discovery preferred part, that we have the prefix and the preferred. That thing it says, achieved by modifying the router advertisement to announce the old prefix with a short lifetime and the new prefix. And these are the options we have: neighbor discovery prefix, and default we have the valid in lifetime, preferred lifetime, all valid data, preferred data, uplink, no auto config, and used to modify prefix advertisements parameters on interface from the default value. And here we have the overriding neighbor discovery default, that we have the two router 1 and router 2, and these are the preference we have assigned. And next slide you will come to know which is going to get the first preference. And here we have the preferred address, which preferred address host is going to achieve, along with the network preference, and then the link local address, what it is going to advertise. And then here you can see on the first part Ethernet having the preference, then 0, and second part is the both options the same. In that case, it is going to get the first preference. So preferred address, there we have, you will see 2001 colon DB8 C18 colon C18, then colon 2, then colon, this is the part. So 2 is become the preferred, and it is going to least prefer, that is the first one. Thanks for the watching. Next time I will send the new series of the content of the how to configure IPv6 addresses. Thank you.